Okay, got 3 different rods I can use now. So I've got these Gorilla rods, 1.25" crank pin, Harley Evo size up here, which is 782, I think, 780, whatever the hell it is, 680, some of them numbers. I got some STD rods that were 1.25" crank pin. Take 875 wrist pin, which is kind of an odd size. So that's 7/8 of an inch pair. These are all 8-inch rods. Then I got the Ultima rod, which was for a twin cam. So these are 927 wrist pin, which is your stock twin cam size. But these have the big hole in the bottom. You take the big wrist pin. Not the big wrist pin. Well, I'll take a big wrist pin. I take a big rod pin too. So they're a little bit bigger than these rods here. See? Same length, but big difference down there. Now, I wonder if I can make these fit onto that big crank pin. Let's see if we can mix and match the components here. No until you try, right? Okay, on this I can use a bigger piston. Otherwise I'll probably use this Gorilla rod. Okay, so let's see what we got for diameter difference. Okay, these ones are 2.1 inches. Set your 0. Over here, read 600 thou difference, 600 thousandths. So I need 300 thousandths spacer to make that work. Then you could put this big ass rod in here and see if it'll clear. It's a little bit bigger than the flywheel, so it'll probably go clunk, clunk, clunk as it went around, if it would even rotate. So I'm thinking it's safe to say this isn't going to work. And I don't have any 300 thousandths bearings laying around either. It's kind of an odd size. Maybe that's what a Timken bearing is. I don't know. Okay, so we're not going to be able to make that work right off the bat. So that's a no-go. Don't know until you try though, right? Okay. Next on the list, do we do a 7/8 pin or do we do a big pin? We'll do an Evo pin. Most big pistons have bigger wrist pins in them. Let's see, I just went through a bunch of wrist pins down here trying to figure out pistons to use for the other mock-up motor. So what do we got down here? This is our junk pile down here. Okay, that's the M8 I was just screwing around with. That's worthless. These here are the one I just used, another one of these, but this has the big pin in it. Oop, get it where you can see it. This is 4 1/8 inch bore. Big pin. This is a big pin also. So most big motors have big pins. Here's this thing. Twin cam oil pump. What do we do? Alright, so the best I can probably do is maybe like a 107 motor, 113. They got 4-inch bore pistons with Evo pin. I think I got a pair of those floating around someplace, but they're not down there in my junk pile. I have new ones. Alright, so it looks like we're going to be stuck with we're going to use those brand new Gorilla rods. That would be this set. Brand spanking new. So if you're going to use junk, might as well do junk. $800 set of rods for mock-up. What the hell? Okay, I wonder if they're honed yet. Doesn't really matter because these aren't fitting for anything. Ooh, those look nice on there. Okay, that is a lot bigger difference than I thought it was going to be. So let's go ahead and do that same trick again. Well, it's only a 1/16 of an inch. It looks like it's more than that, but it's not. Can't be more. It's 1 5/8 and 1 1/2. That's only an 1/8 inch difference. Doesn't matter what it looks like. Okay, so boom, brand new parts. Okay, is this rod going to hit like the last one did? Oh, this one actually closes. Yep, no it does not. It hits right there. Boom, hits right there, see? So this motor we can't even turn nearly as much as the other motor. We can go half a turn till it hits. Boom. Okay. Okay, so what I'm going to do is I'm going to take some cardboard and start making laps. So I always keep a little bit of gasket board material over here, just in case we need it for making stuff. And what do we got over here? Paper. This is thin paper. Take a few sheets of that to do anything important. Got all my gasket board material. There's a bunch of material under here. Cardboard box. Can use that. I gotta get rid of most of my good stuff. There's some material right here we can use. This looks pretty good. A little bit thinner than I like, but just put more layers. There we go. Or I can use a piece of this right here. It's about the right thickness too. It's not long enough. Yeah, that would probably... How thick is this? 53 thou. That's pretty close. How thick is this? 30 maybe? This is 40 thou. 2 layers of that would be tight. Okay. Good thing I know how to work scissors on. Okay, so this is precision workmanship here. This is undersized paper now because I tore it. Okay, we're gonna go over here to the full size stuff. Okay, so we gotta figure out how wide we need it. 1 3/4 inches would work. 1.8 inches. So 1.8 inches. Somewhere. I knew I had a pen. Okay, 1.8 inches. Right there. How much length do we need? Does anybody know how much length we need to go around an 1.5 inch crank pin? should you be able to just take a simple number like pi, which is, what's pi? 3.14, I think is close enough, isn't it? I forget what pi is right now. One of these symbols up here might be pi. What's that? 0. That doesn't mean nothing. I think it's 3.14. Close enough. Times 1.5 inches. Just under 5 inches. 4 3/4 inches. Make our first piece and try it out. Four 3/4 inches is right there. Okay, there's our number. Long enough? Yeah. It's good. Oh, we need more than one layer though, don't we? This is only 40 thou. Forgot about that. Length. Okay, this is 40. We need a 1/16 of an inch, right? Yep, that's 40. So we need 20. We need something that's 20 thou thick. It's just 9 thou per side. Too damn thin to be of any value. I wonder if I can just jam this in there. Maybe I can just jam this in there. Okay, we got what, 4 3/4 inches? That means we're going to need at least another 5 to go all the way around. So we'll just cut this whole thing down. Be just about right. 1.8. A little short down here. Someone used a piece of it already. Wonder who that was. Okay, we'll just continue down the road here. Okay. Look at that, right on the edge. My pi number worked. Cut a little extra. Alright. Well, this should be too much material. We'll find out. Now this is not a true bearing, so you cannot run this down the freeway unless you absolutely had to. Remember that unless it absolutely had to, then it would work. Okay, this is not going to fit on here. Guess what? It does not fit on here. You know why it doesn't fit? Because it's the wrong size. Okay. But we knew that. Just want to make sure. Okay. How close am I to my number? Look at that. 4 3/4 inches to be like 1/8 of an inch. Damn, see my pi works? See, math does work. That's a little extra long because we didn't go off the center line dimension. There you go. Because you actually have to go off the bolt circle or the center line dimension to get your full length. So that's why I was a little bit longer. Okay, that will work. Look, I got 2 pieces. I have an extra one. If this bearing fails, I have another one backup. Throw that in my toolkit. That way I can get to the grocery store and then get back home too. I have to rebuild the motor in between, but I can make it. I got confidence. I can make it work. Yeah, that's pretty damn nice right there. It's a little loose, but it works. Okay, so we're going to take some of this. Here we have a sample of what we need right here, see? You need 2 layers of this. And that'll give me about 5 thou clearance for a racing fit. So if we need 2 layers, I need a full sheet here to make this work. Okay. There we go. Look at that. I'm going to cut on the inside of the line this time, not on the line. Now we want to have this on the inside or the outside of the paper. This is a finer material, so we'll run this on the outside. We'll run the coarse stuff on the inside. How's that? Getting pretty complicated here. Okay, now this is going to be under a little bit of a loaded condition here. It should be about a 1/2 inch long at least. Pretty close. Not sure where the step's at. I don't have the step at. Right dead center. Look at that, right there. Pretty good for a guess, huh? About a 1/2 inch too long. Probably closer to 5/8, but yeah, close enough for dumbasses like me. Okay, so do not overlap in the same spot. Okay, now this should just go on there with a little bit of clearance. Quite. I can't get it all going tight. A nice fit. A little bit snug. But I need to put the rest of it in there. Hello. No. Working on my race bike. Oh, poor Scooby had to go out by himself. Yeah. Alright, I'll be a while. I'm working on the race motor, so I'm playing. Yep. No, I said I'm working on the motor. I didn't say I was racing. That's 2 totally different things. Yeah, probably another hour. Yep, that'll work. Alright, bye. Okay. that would be a wellness check to make sure I'm still well. Didn't kill myself yet. All right. Scooby had to go outside all by himself. Poor little dog. Okay, we're going to try it like this. See if we can assemble this. I took a little bit out of the cardboard because it was pinch tight. So I need a little room. Okay, let me see if I'm doing this correctly. Yes. Okay, we'll let gravity work with us here. So I don't know if this is going to fly or not. Try. Tight squeeze. Screwdriver. Ah, not quite. Thought I had it. Look at that. What do you mean you got the wrong parts you can't make a mock-up out of? Haha! The hell you can't. Okay. So we got a little bit too much material sticking up, but it'll squeeze in when we tighten the damn thing down. Okay, now this presses together. I'm not sure how that works because I haven't done one lately. So the first thing I'm going to do, we'll get some press fit lube to go on that. So we got some press fit lube right here. Damn, this stuff is so damn hard from being cold. Okay, don't mind wasting this a little bit because flywheels cost a lot more than lube does. Okay. Let's see, we're going to have to get this set up in the press. All right, let me go over the press, get this set up, we'll be back.